Okay, so this is transistor characteristics in CE mode. So we are going to notice the input and the output characteristics for a given transistor, and we are going to calculate the alpha and beta values of the transistor. Now, what do we mean by input characteristics? We mean the input current versus the input voltage that we give. So we are going to plot that for a constant output voltage, that is VCE, and by output characteristics we mean we are going to plot out the output voltage versus the output current, that is VCE versus ICE, for a constant input current. Alright, so I'm going to help you with this circuit diagram a little bit to show you that this circuit isn't that difficult to remember. So first of all, what we're going to do is start off with a BJT, bipolar junction transistor, and make it into an amplifier. What we do is here's the base, here's the collector, here's the emitter. We're going to collect a collector resistance, and then we are going to use a voltage source across it. The emitter has no resistance across it and it's grounded, and the base, it has a resistance and also a voltage across it. Now this is basically our diagram. Now what are these things that you ask? These are only the measurement equipments that we use. So usually what you need is, you need to measure the base current, you need to measure the collector current, you need to measure the base voltage, so you need to measure this voltage across this and the resistance. So you're going to measure a voltage here, and you're going to measure a voltage across this thing. So those things, when you add them up, you're going to see this diagram. That's it.
And for the ammeter, you just have to connect it in series with the source.
Exactly. So you connect.
Now for the input characteristics, just refer to the table. What you basically has to do is you have to keep the VCE, that is the voltage across the collector and emitter region, constant, and then you have to vary VBE, that is the input voltage or the base emitter voltage, and then the output will become as the IB, that is the input current, that is the base current. So our first task is to set VCE to 2 volts. In this board, as you can see, there are blue lines here and everything is mentioned. So wherever these lines are, these are all internally connected. But as there are points, for example, this P and A, these are not connected. Q and D, they are not connected because in the diagram that is drawn here, it's not connected. So we have to connect it manually. That is, we'll connect Q to D and then P to A, and similarly here G and S and here F and T. Now, so first we'll do the connection for these 4. All 4 of them are connected. Now as you can see, everything is internally connected. Now the only thing we need to connect is the voltmeter and the ammeter. So first we have to connect the milliammeter to the IC region. In the diagram only here it is mentioned that where you have to connect the positive and where you have to connect the negative. So you don't need to get confused. You just have to follow what's written here. For example, the positive terminal here will be connected to the positive side of the milliammeter, and the negative terminal is connected to the negative side of the milliammeter. Similarly, here we have a microammeter, so we will be connecting the positive side of a microammeter to the positive terminal of the microammeter, and same goes for negative. Also guys, make sure the connections are tight, because if the connections are loose, then you might get some funny readings. So this is our basic connection. Now we have a voltmeter here, and according to the graph, first we have to keep VCE constant as 2 volts. So first we'll connect the positive side of the voltmeter to the positive side of the VCE. As you can see, there's VCE here, this is the positive terminal and this is the negative terminal. So for the negative side of the VCE, you'll connect it to the negative side of the voltmeter. Now let's switch it on. Now there are 2 dials that will help us in changing the voltage values. As you can see here, this is the VCE value, and we have to put it to 2 volts first. So this is for fine adjustments, that is for very small adjustments, and this is for coarse adjustment, that is if you want to take a bigger adjustment, for example from 2 if you want to go straight to 4 or 6, then you can use this. But for example here, if you are in 1.9 and you have to go to 2 or 2.10, then you can use this. Here as you can see, this voltmeter indicates VCE value, that is the output voltage value. As you can see, we have connected VCE terminals to the voltmeter. Now what input characteristics wants is that we have to keep VCE value first as 2 volts. So we will be using the fine adjustment knob to get closer to our value as soon, and I think so this will do. As you can see now, as we got 2 here, you don't have to meddle with these. Now you have to take the VCE wires out, and you have to connect. I'm taking a bigger wire here. Yeah. Now you have to connect it to the VBE, because now we will be changing VBE. So as you can see, we have VBE here, and the negative side of it will go to the negative, and the positive side will go to the positive. Another point, if you have a multimeter lying around you, and if you think by accident this knob might be changed, you can use this multimeter to get the VCE value, that is. So as you can see, I've connected this multimeter to VCE, so that you just have a reference here that it is set to 2. Like for example, it is 2.15 here. If I want, I can like just make sure it's up to 2. Again, this is not a necessary thing to have, because you might not get a multimeter there. So it's just for your ease, like while doing the experiment, if you think you have messed with the knobs, that's why, just for your reference it should be. Okay, coming back to the experiment. Now we will be changing this knob. This knob is to change the VB value, that is the VBE value. Now as we increase it, so as you can see, this will show at what voltage are we the VB value is, and we have to take the output from here, the microammeter. Take the values in such a way, for example, if we start with the lowest value, take values from 0, 0.1, 0.2, 3 and so on. And so guys, this shows the VBE value, and this is the IB value. So this will be our input for the input characteristic, and this will be our output for the input characteristics graph. So let's change this knob, will change the VBE value. Now what you guys have to do is note down the readings for, like for example, for 0.1, then 0.2 it is 0, for 0.3 also, and so on. For every 0.1 distance, note down the readings, and yeah, and then note down the value at which it is getting 1 microamps it is getting, and then take values accordingly, like the way it is increasing, take values. For example, in 67 it is 21 and so on. So, and again do the same experiment while changing VCE to 8 volts. We did this for experiment for VCE is equal to 2 volts. Now in order to change it to 8 volts, you have to do nothing but take these VBE points out, and now change this to 8 volts. As you can see in the diagram, we have 8 volts here. We have completed the experiment for VC equal to 2 volts. Now we'll do for the 8 volts, that is okay. Once you have set it to 8 volts, now take off VCE again and put it back to VBE, and hence repeat the same experiment while changing this knob and taking down the values.
Alright, so output characteristics. So we are going to set a constant IB current, and for that constant IB current we are going to vary VCE and again we're going to note down the corresponding IC values. Let's do that. So first of all, IB equals 30 microamps. We can change the IB value by changing the VBB voltage. Let's set that to 30. It's almost 30 here. Okay, 30. Now let's set this to 0. Make sure that your voltmeter is reading the VCE values and not the VBE values from the previous portion of the experiment that you have done. So it's at VCE values. We're going to see VC equals 0, and then we're going to note down this IB values. So VC equals 0, IB is about 0. It's exactly 0, my bad. Next we're going to increment in voltages of 1. Let's go to 1 volt. So at about 1 volts, you can notice that your IC value is 8 milliamps. Next you're going to measure 1.5. It's almost the same, and so. So you're going to increase your VCE value, and most probably what you're going to see is almost a constant IC value. So you're going to do that. It will change after a while, and that's it. So you note them down. What you need to do next is change your IB value to the next value, that is 60 microamps. So we're going to do that. Make this 60 microamps. Okay, this should be close enough. And again we're going to repeat the thing. So we're going to check the current for IC. Oh yeah, make sure that it's at 60 when you're sitting at 0 VCE voltage. So we're going to repeat the same experiment for IB equals 60 microamps. We're going to increase the VCE voltage, and we're going to make sure it's still sitting at 60, and we're going to note down the current across the collector. So say for 1 volts approximately, we're going to make IB is 60, and we're going to note down this value. Similarly, you're going to do the same thing for all the values and note them down on your table, and also note the same values for IB equals 90 microamps. And that should conclude the data taking part of your experiment. What you're going to do next is make a graph. Okay, now that you have all the data points, what you're going to do is plot them onto a graph. That is, you make an input characteristics graph and an output characteristics graph. Now to do some calculations, for example, we need beta and alpha values here. We need to do some things to the output characteristics graph and find. Numerically, beta is defined as you can see here, delta IC by delta IB at a constant VCE voltage. So we have constant IB line here, constant IB line here, constant IB line here, and what we want to find is delta IC. So we're going to extrapolate any two of these lines backwards so that they touch the y-axis. So we're going to trace back our straight lines, the straight line portions of our graph backwards up until they touch the y-axis, and then we're going to measure the distance, or note down the distance between A and B, and that will give you delta IC for a corresponding IB, delta IB value. So here delta IB would be 60 microamps minus 30 microamps, and that would give you 30 microamps. You can see it here. Delta IB is 30 microamps, 60 microamps minus 30 microamps, and delta IC, which from this point we can find out is 0,18 and 0,9.75. You subtract those and you get about 8.25 into 10 to the power minus 34. So you do that and you divide them, and then that will give you the value of beta. Now that you have found out the value of beta, you want to find out alpha, and that is found out using this simple formula which you can input into your calculator and get out alpha. And that concludes our experiment. Thank you.